of total internal reflection. Okay, so first of all, let's just okay, so so the first example that we have is an optical fiber. Okay, now an optical fiber is made from a glass. So let's say if we have an optical fiber that looks like this. So we have this optical, we draw this optical fiber again. Okay, so we have an optical fiber. Acha, optical fibers, beta, they are made from glass and they are responsible for the transmission of the internet. ठीक है? So optical fibers are usually for the internet cables. Okay, so this is an optical fiber which is made from glass. Now let's say, beta, we have a light ray that is incident. So this is a light ray. Acha, now what happens when the light ray is incident? When it strikes the surface of the glass, because it's actually now traveling inside the glass. So what happens? Glass is a denser medium. Now your angle of incidence is greater than the critical angle. So since your angle of incidence is greater than the critical angle, so this light is reflected back inside. Okay? And when this light is reflected back inside, because it goes total internal reflection. Now again, the light ray gets reflected back when it reaches this point. अच्छा, जब भी अगर light ray आपकी surface को hit करती है, we draw a normal to the surface. ठीक है? Now keeping in mind that the angle of incidence and the angle of reflection is equal, so we draw the reflected ray. Okay, so here is another incident angle and this is the reflected angle. Okay, so beta, you can see that this light, it undergoes the phenomena of total internal reflection. So basically instead कि the light ray just travels outward, ठीक है, it reflects back inside and it's undergoing the phenomena of total internal reflection. अब एग्जाम में आपको ये भी आ जाता है कि वो आपसे ये कहता है कि complete the path of the ray. Okay, so every time you draw the reflected ray, please draw the normal line first. So ये जो dashed lines हैं, these are the normal lines, and then keeping in mind that the angle of incidence and the angle of reflection is equal, you draw their reflected rays. So this way the light ray just travels inside the glass. Okay, now I hope it's clear. ठीक है? So how does it works? As light ray hits glass surface, so जैसे ही लाइट आपकी ये ग्लास के सरफेस को हिट करेगी, so its angle of incidence is greater than the angle than the critical angle. ठीक है? So light undergoes total internal reflection. So since it goes total internal reflection, so we can say that the angle of incidence becomes equal to the angle of reflection. Okay. Now, why do we use optical fibers? ठीक है? Because these optical fibers are lighter compared to the copper wires. ठीक है? So let's see कि what are the advantages of using. अच्छा, अब देखो बेटा, जो कॉपर की वायर्स होती हैं, कॉपर वायर्स आर एक्सपेंसिव. ठीक है? सो दीज ऑप्टिकल फाइबर्स सिंस दे आर मेड ऑफ ग्लास, so they are cheaper compared to the copper wires. So the first one is optical fibers are cheaper than copper wires. अब ये ऑप्टिकल फाइबर्स आपकी जो ये इंटरनेट केबल्स होती है ना, दीज इंटरनेट केबल्स आर मेड ऑफ दीज ऑप्टिकल फाइबर्स. ठीक है? सो दे आर चीपर देन द कॉपर वायर्स. Second important thing is that they carry much more information than the copper wire. Okay? So they carry much more information than copper wires. So copper wires can only carry a limited amount of information and they transfer the information at a quick rate. They, they transfer information at a quick rate. And they are lighter and easy to handle. So copper wires, since they are totally metal, the metal is much heavier compared to this. So these are lighter and easy to handle than the copper wires. अच्छा, एंड देखो, सिंस लाइट जो है, स्पीड ऑफ लाइट इज द फास्टेस्ट, which is 3 into 10 to the power of 8 meter per second, and it transfers the information at the speed of light. So that's why it's very fast or it's very quick. Or this is the reason कि let's say if I am delivering a lecture right now, ठीक है, and you're able to just hear me out within a margin of let's say few seconds. तो इतना क्विक इंफॉर्मेशन जो है दैट इज बीइंग एबल टू ट्रांसफर. ओके. एंड and they transfer the information without any interference. So they transfer information without any interference. So basically the copper wires, they have a lot of interferences, resistances, जिसकी वजह से losses जो है they are extremely high. Okay, now let's just talk about another example, and that is about a periscope. I hope it's clear. ठीक है? So we had this glass tube, optical fiber. We had a ray of light which was incident. So this was the incident ray. Why it undergoes the phenomena of reflection, total internal reflection? Because the light ray is inside the glass. ठीक है? And when it reaches the surface boundary between the glass and the air, so between the glass and the air. So what happens? The light gets reflected back into the same medium, and the angle of incidence and the angle of reflection is equal. Okay, so you have to keep this thing in mind, or the normal line is the line that is perpendicular to your surface. Okay, now let's just quickly talk about another application, and that is about the periscope, and then we'll do some numericals as well. So second one is, let's say, a periscope. Okay, so let me draw. Okay, so better, let's say we have this periscope and a person. So these periscopes are installed in a submarine, right? Okay, now we have two right-angled glass prisms. So we have these two right-angled glass prisms. Let's say we have an object placed here. So it's a bird. Okay. So we have this object. Now what happens? The ray of light is incident from this object. So this ray of light. Okay. So we have this ray of light from the object that is incident over here. So what is this? This is basically a glass prism. Okay. Now, now what happens? It goes reflection. When this light ray is incident on this glass prism, so what happens? It undergoes reflection. So keeping in mind the angle of incidence and the angle of reflection should be equal, this light ray gets reflected, and when it again reaches this glass prism, so what happens? Again, the angle of incidence and the angle of reflection will be equal. So the light ray gets reflected and then it reaches the person. And this is how the person is able to observe the object. Okay. So the light ray that comes from the object, it strikes the glass prism. It follows the phenomena of reflection. ठीक है, keeping in mind the angle of incidence and the angle of reflection is equal. Then it gets again reflected and then it reaches the person. So basically, we use a periscopes in a submarine, right? From where we have these periscopes, and we are able to, while sitting inside the submarines, we are able to observe के what is happening outside, ठीक है, or what is happening above the ocean or above the sea. So this is how it works, a periscope. Now let's just do few numericals and questions that involves critical angle as well. So the first question is, let's say if he gives us the critical angle of a glass is, let's say, 42 degrees. So critical angle of glass is given as 42 degrees. Now we have to calculate first the refractive index. Second we have to calculate the refracted angle if light travels from air to glass at an angle of incidence of, let's say, 36 degrees. Okay, so this is a question. So the first part we have to calculate its refractive index. So we'll use the second formula for the refractive index, that is n is equals to 1 over sine c, where c is the critical angle. So the value of c is 42. So we will get 1 over sine 42. So let's put this value on the calculator. 1 over sine 42, we get 1.49. So बेटा once you have the refractive index, फिर अगले part में वो कहता है कि calculate the refractive index if the light travels from air into the glass at an angle of incidence of 36 degrees. So basically अब वो आपसे ये कह रहा है कि एक ray of light है वो air से glass में travel कर रही है, and this is the its angle of incidence is 36 degrees. So when it travels from air into the glass, it just bends towards the normal. So he's asking us to calculate its refracted angle. So we'll use the other formula. N is equals to sine I over sine R. So N की value we just calculated at 1.49. Angle of incidence is the angle which is in the less denser medium or in the air. So angle of incidence हमेशा air वाला होता है और refractive index refracted angle हमेशा dense medium वाला होता है. तो sin 36 over sin R. Now what we do? Acha, now we're going to swap the positions of sin R and 1.49. So sin R equals to sin 36 divided by 1.49. So let's see what do we get. Sin 36 divided by 1.49, 0.394. So 0.394. Now when you shift sine to the other side, we take sine inverse. So we will take sine inverse of 0.394. So once you take sine inverse of 0.394, so you will get 23.2 degrees. So this is going to be the refracted angle. So question में we were provided with the critical angle, ठीक है? And then he asked us to find out its refractive index. You will use the formula n is equals to 1 over sine c. Put 42 in the formula. So whole expression on your calculator, you got 1.49. Then he said, if the light is traveling from air into the glass and the angle of incidence is 36 degrees, so calculate its refracted angle. So we use the other formula, n is equals to sin I over sin R. Use the value of n that you calculated from the previous part. फिर उसके बाद इन दोनों की position swap की, and then you take the sine inverse and you got the value of the refractive index. Okay, let's discuss one more question. So these are the type of questions that you get in your exam as well. Okay, so let's say the question is, so we have, so basically a ray of light, it travels from glass into the air. Okay, or glass की जगह, now let's say I'm going to use water instead. Okay, so a ray of light, it travels from water into the glass. Okay, and so this is the, okay, so this is an angle of 54, and let's say this angle is let me mark it as 56. Okay, now we have to calculate Part 1 we have to find out its refractive index, and part 2 we need to find out its critical angle. Okay, so first of all, to calculate the refractive index, beta, you need to find out कि what is the angle of incidence. ठीक है, और basically आपने let's say even if this is the incident ray, तो आपने incident और normal line के दरमियान वाला angle find करना है. So 90 minus 54, 90 minus 50, 40, 40 minus 4, so this angle is 36. So we water में angle है 36. Water is a denser medium. ठीक है, air is a less dense medium. So if I'm going to use the formula of refractive index, sin I over sin R, I is the angle which is in the air and I should be greater than R. So sin 56 divided by sin 36. So let's just put the values on the calculator and see okay, what is the value that we get. So 1.41. So the refractive index is 1.41. The other part, we need to calculate the critical angle. So we use the formula n is equals to 1 over sine c. Okay, let's swap the positions of sine c and n. So sine c equals to 1 over n, or n की value we just calculated as 1.41. Now if I shift sine to the other side, I'm going to take sine inverse of this whole expression. So sine inverse of 1 over 1.41. So we get 45.2. And if I round off the answer to two significant figures, so 45 degrees is the critical angle. So you'll get numericals based on this. अब ये कितने कितने mark का आएगा? 2 mark for the first one, 1 mark for the formula, 1 mark for the answer. Yeah, this one is going to be for 3 marks, and 1 mark if you use correct values of incident angle and the refracted angle. Now the other part is going to be for 2 marks, 1 mark for the formula and 1 mark for the answer. Okay, so I hope it's clear to all of you. If you have any questions, so please feel free to ask, beta.